Good morning, grade 9 students. We will talk about illustrations of quadratic equations. So what's new? Bernard is planning to buy a farmland in Marilao. A farmer who is not sure of the dimensions of the farmland where he is working on, which happens to be for sale, gave Bernard an approximation of the length and the width of the area in meters. Okay, so here is the illustration. So this is the farmland. Okay, so as you can see, the length is unknown, okay, or x. Let's have variable x to represent the length of the farmland. And the width is, you will just add 20 meters on our length to have the width, which is x plus 20. Okay, so the area of a rectangular region is length times width, where w is represented by x, and the length is x plus 20. The area now, we will just substitute the value for L and W. L is x plus 20. You will have here x plus 20 multiplied to the width, which is x. Okay? So by distributive property of multiplication, you will just multiply x times x, you will have x squared. And then 20 times x, or x times 20, you'll have 20x. This is now our equation. So this is another kind of equation which is different to a linear equation. Okay? So this is the area of our land. A few minutes of conversation with the farmer, Bernard called the landowner and was told that the area of the land is 8,000 square meters. So that means we can now substitute the value of the area, which is 8,000 square meters, to our equation. So here is our working equation now. X squared plus 20x equals 8,000. So this is another kind of equation which is very different to your linear equation learned, or what you have learned on your grade 8 mathematics. Okay, so what is it? Quadratic equation. This is what we call the equation earlier. A quadratic equation in one variable is a mathematical sentence of degree 2. That means the highest exponent that you can see on the variable x is 2. It can be rewritten or written in its standard form, which is ax squared plus bx plus c equals 0, where a, b, and c are real numbers. Real numbers are counting numbers, integers, negative numbers, okay, and decimals, fractions. But there is still a restriction where a should not be equal to 0. From our standard form, ax squared plus bx plus c equals 0, ax squared is called the quadratic term, and bx is called the linear term. Lastly, c is called the constant term. Here are examples of quadratic equations. X squared plus 2x plus 1 equals 0. So as you can see, the degree is 2. Here, the highest exponent that you can see on the variable x is just 2. Okay, so this is a quadratic equation. On the next one, 3x squared minus x equals 2. This is not equated to 0, but still it has a degree of 2. This is still a quadratic equation. Here are the non-examples. Non-quadratic equations. So you have x minus 3 equals 0. This is called the linear equation. X equals 5 is also a linear equation, the second non-example. And x cubed plus 3x squared minus x plus 2 equals 0. Even though it is equated to 0, the highest exponent is 3. That means this is not a quadratic equation. We will have more examples on our virtual board. For the first example, we have 3x squared minus 4x plus 5 equals 0. So as you can see, the highest exponent that you can observe on the variable x is 2. That means this is a quadratic equation. This term, 3x squared, is what you call the quadratic term, which comes first and then followed by negative 4x. This is your linear term, and the last term, which is 5, is called the constant term. Let's go now to our second example. In the second example, we have x times the quantity x minus 1 equals 0. It is not obvious that this is a quadratic equation, but actually it is a quadratic equation. So all you have to do is to simplify the equation by multiplying x to the terms x minus 1 on our quantity. So you will have x times x, that's going to be x squared, and then x times 1, you will have x times negative 1, rather, you'll have x squared minus x equals 0. So this is now obviously a quadratic equation. Okay? It is also in the standard form. Quadratic term comes first, the linear term follows, and since we do not have a constant term, that means that our constant term, which is c, is equal to 0. Okay, in this example, we have x squared plus 4x equals 0. It is a quadratic equation in standard form, even though the constant term is 0. On this fourth example, we have 5x squared minus 7 equals 0. It is also a quadratic equation, even though the value of b is 0. So as you can see, we do not have a linear term. And we have our constant term, which is negative 7. We do not have a linear term. Okay, so that means b is equal to 0. On our fifth example, we have 3x squared minus 2x plus 1 equals 0. Let's identify the values of a, b, and c. So the value of a here is the numerical coefficient of the quadratic term, which is 3. The value of b is negative 2, and the value of c is 1. Another example is this. In this sixth example, the value of a is 1. Since we do not have a linear term, that means b is equal to 0, and c is equal to negative 1. Let's proceed to our next example. On our seventh example, we have 3x minus 5x squared equals 4. This is a quadratic equation, but it is not in its standard form. So we will rewrite it in its standard form. So we will just copy this first. Okay, so as you can see, we have 4 on the other side of the equation. So we will add negative 3x plus 5x squared on both sides of the equation to eliminate these two terms, to make this left side of the equation be equal to 0. So let's add negative 3x plus 5x squared. Okay, also on the other side of the equation, negative 3x plus 5x squared. To make it clearer, let's rewrite this one. Okay, negative 3x, then just have 5x squared. And then 4 plus, minus 3x and then plus 5x squared. As you can see, we will have here 3x minus 3x, that's 0, and then negative 5x squared plus 5x squared, that is also equal to 0. That will make this whole quantity, 4 minus 3x plus 5x squared, be equal to 0. Let's rewrite this. Or let's rearrange these terms such that the quadratic term should come first. We will have 5x squared and then followed by the linear term plus 4 and then equals 0. So now it is in its standard form. Okay, next. Okay, On our 8th example, we have x squared equals 4 minus 2x. Let's just rewrite this into its standard form. Okay, so we will add negative 4 plus 2x on both sides of the equation. That is the same with having x squared minus 4 plus 2x equals, just copy this, and then what you did on the left side should also be done on the other side of the equation. So minus 4 plus 2x. So as you can see, we added negative 4 and 2x on the other side, and negative 4 and 2x on the right side. Okay, and then let's simplify. So we will have now x squared. Okay, maybe we can arrange this two such that the linear term should come first. So you'll have plus 2x minus 4. On the right side of the equation, you will have 4 minus 4, that's 0. Negative 2x plus 2x is equal to 0. Now, we will have the standard form of our given equation. Okay, so let's go to the 9th example. The 9th example, we have x squared minus 5 plus 12x equals 11x minus 3. So all we have to do is to make this side of the equation be equal to 0. The right side of the equation. So to make it equal to 0, all we have to do is to subtract 11x and add 3 on both sides of the equation. So here is what you're going to do. Just copy first the given, and then subtract 11x that came from here, and then add 3. On the other side of the equation, you'll have 11x minus 3. Okay, just copy that from here, and then subtract 11x, then minus 3. Okay, so let's simplify this now. Let's combine like terms. X squared, there is no other term which has to go through here. Okay, and then the constant term should be the last term. That means let's evaluate first this one. 12x minus 11x, that's going to be positive x or plus x. And then negative 5 plus 3, that's going to be negative 2. Equals 11x minus 11x, that's 0. Sorry, this should be plus. Okay, negative 3, then plus 3, you will have 0. So you will have 0 on the right side of the equation. This is now in its standard form. Okay, on the 10th example, a rectangular lot with an area of 30 meters squared. So let's have the given. Area is 30 meters squared, or square meters, has a length of 1 meter longer than its width. So that means the length is the length is 1 meter longer than its width. So that means W plus 1 meter. Okay, and then what should be the quadratic equation that represents this situation? Okay, so let's see. So since the area is equal to length times width, okay, and A is equal to 30 square meters, our length is W plus 1 multiplied to W. We will have now 30 equals by distributive property, we will have W squared, and then 1 times W, that's W. We will have now a quadratic equation which is 30 equals W squared plus W. But if you are asked to write the standard form of the equation, you will come up with this, W squared plus W. Other students find it easier to use this method, a shortcut method of having, for example, this 30 written on the other side of the equation becomes negative 30. We will change the sign of that term. So that becomes minus 30. That means you will have 0, which is equated to W squared plus W minus 30. It's now standard form. Okay, so for the last example, 11th example, we have this problem. Tim is twice as old as Mitch. The product of their ages is 18. To represent this in a quadratic equation, we will translate the given information first. Okay, so you will have Mitch's age is X. So let's say Mitch. That's 4. That's X. And then Tim's age is 2X. Okay. Since the product of their ages is 18, that means you will have 2X times X is equal to 18. And then, by multiplying 2x and x, you will come up with 2x squared equals 18. Afterwards, you will divide both sides by 2. Simplify the equation. Then you will have here 9. So you will come up with x squared equals 9. Okay? The shortcut that I told you earlier on eliminating this 9 on the right side of the equation and putting it on the other side of the equation by just changing its sign. So for example, you have 9, that becomes negative 9 on the other side of the equation. So you'll have x squared minus 9 equals 0. Now, we will have the equation that represents the scenario of Mitch and Tim's age. Okay, so I think that you are ready on answering the activities of your modules, and then let's see if you answered them correctly. Thank you very much.